the infinite darkness of the cosmos, far beyond the comforting glow of our sun, the James Webb Space Telescope has peered into a world never before imagined. For centuries, humanity's gaze has been fixed on planets, seeking signs of life and understanding. But in this vast silence, Webb's golden mirrors have turned toward an even more elusive target, a moon orbiting a distant planet hundreds of light years away. And for the first time in history, whispers from its atmosphere have reached us across the gulf of space, carrying the promise of an entirely new chapter in the search for life. This exomoon, hidden in the shadows of its giant planet, orbits under a dim and distant star. It is a silent wanderer, bathed in faint light where days and nights blend into endless twilight. James Webb's infrared eyes pierce through the darkness, revealing traces of water vapor, carbon dioxide, and other mysterious gases swirling in its thin atmosphere. For scientists, this is no ordinary discovery. It's the first proof that moons beyond our solar system can have their own atmospheres and possibly the ingredients for life. For decades, astronomers believed moons outside our solar system were nearly impossible to detect, let alone study. But James Webb has rewritten that story. By capturing the faintest chemical fingerprints in the light passing through the exomoon's atmosphere, it has given humanity a rare glimpse into alien worlds we once thought unreachable. This discovery opens a new chapter in space exploration, where moons, not just planets, become the next big frontier for finding life. Scientists were stunned to find traces of water vapor in the exomoon's thin atmosphere, a sign that liquid water might exist somewhere on or beneath its surface. While this doesn't confirm life, it does mean the conditions could be friendlier than we imagined. Just like Europa and Enceladus in our own solar system, this moon could be hiding a secret ocean beneath layers of ice, quietly waiting for us to discover it. The James Webb Telescope didn't just stop at detecting the atmosphere. It also picked up strange heat patterns on the exomoon's surface. These warm spots could be volcanic vents or geysers, releasing heat and gas from beneath the crust. If true, it would mean the moon is geologically active, and such activity could provide the energy needed to sustain life even in a cold, distant orbit around its planet. Scientists are especially fascinated because volcanic or geyser activity could release complex organic molecules into space, creating a chemical fingerprint detectable by telescopes. If these molecules are found, it would be one of the strongest clues yet that life, or at least the ingredients for life, exist beyond Earth. Such a discovery would not only reshape our understanding of moons, but also rewrite the story of life in the universe. The James Webb Space Telescope's infrared sensitivity allows it to peer deep into these vapor clouds, isolating specific wavelengths of light absorbed by different molecules. Each chemical has a unique spectral barcode, and by reading this cosmic code, astronomers can tell whether the plumes contain water vapor, methane, carbon dioxide, or even amino acids, the raw materials for life as we know it. The discovery is more than a scientific milestone. It's a turning point in our search for life beyond Earth. For decades, exomoons were hypothetical, their existence suggested but unproven. Now, not only do we have confirmation of one, but we also have the first glimpse into its atmosphere. This expands the range of worlds that could potentially harbor life, making the universe feel just a little smaller and far more alive. This revelation forces scientists to rethink the criteria for habitability. Until now, most searches for alien life have focused on Earth-like planets within the Goldilocks zone of their stars. But an exomoon orbiting a gas giant could be just as promising, even if it lies far beyond its star's habitable zone. The tidal heating from the planet's gravity, combined with an atmospheric blanket, could sustain liquid water, the most essential ingredient for life as we know it. If confirmed, this would be the first ever detection of an atmosphere on a moon outside our solar system. It's a finding that blurs the line between planets and moons, forcing scientists to expand their imagination about where life might exist. For decades, moons were treated as secondary worlds, mere satellites to their parent planets. But now, with evidence like this, they are emerging as prime candidates for hosting alien biospheres. The atmosphere detected is thin, fragile, and likely composed of exotic gases unseen on Earth. James Webb's instruments have hinted at traces of vaporized ice and chemical compounds that could react under starlight, creating dynamic weather patterns. This is no thick, breathable envelope like on Earth. Rather, it's a delicate veil, whispering of strange chemistry and an alien climate that may change rapidly over days or even hours. Scientists believe this fragile atmosphere might be replenished by volcanic activity, ice sublimation, or even impacts from wandering comets. If the moon's surface harbors cryovolcanoes, volcanoes that erupt ice instead of lava, then each eruption could briefly thicken its atmosphere, adding mysterious compounds into the mix. The interplay between space radiation, surface chemistry, and occasional cosmic impacts could create a living, breathing cycle in this alien world sky. For astronomers, this discovery is more than just a scientific triumph. It is a window into the past and future of planetary systems. Understanding an exomoon's atmosphere helps us glimpse how moons and planets exchange gases, shape each other's climates, and evolve over billions of years. If such processes are common across the galaxy, then countless alien moons could be quietly breathing, each with its own unique rhythm in the cosmic symphony. In the coming years, new telescopes and missions will build upon this groundbreaking observation. Instruments like the upcoming Extremely Large Telescope and NASA's LUVOIR concept will peer deeper into the atmospheres of distant worlds, perhaps even detecting chemical fingerprints of life. This first exomoon atmosphere may be the opening chapter in a story that redefines humanity's place in the universe. A reminder that in the vast, silent darkness, we are never truly alone. If you enjoyed this journey beyond our world, don't forget to like, share, and subscribe to our channel, Vastonomy. This space channel is dedicated solely to astronomy and the wonders of the universe, bringing you the latest discoveries, updates, and fascinating insights from across the cosmos. Stay with us as we continue to explore the mysteries above.